we have Marc Damhaut at Euresys, who's going to kind of complement that presentation with a bit of an extension talking about CoaXPress-over-Fiber. So Marc, the floor is all yours.
Thank you very much, Greg. And thank you very much, Patrick, for this nice presentation of CoaXPress. So we are going to talk about CoaXPress-over-Fiber. And well, it's not a mystery. CoaXPress-over-Fiber is a way to extend CoaXPress to use fiber optics. But as I will show in this presentation, is that CoaXPress-over-Fiber is more than just that, because of the way we have designed it. We have designed CoaXPress-over-Fiber as a way to run the CoaXPress protocol as it is, unmodified with all the advantages of CoaXPress, over a standard Ethernet connection. So Ethernet is actually the Ethernet network. So the RG45 network port that we have on our PCs, that becomes something else. We'll talk about this later at higher speeds. So Ethernet is the base for GigE and for GigE Vision protocols. CoaXPress-over-Fiber uses standard electronics, chips, IP cores, connectors, and cables designed for Ethernet. But the protocol itself remains CoaXPress, as it is, as I said, unchanged, unmodified, not Ethernet and not GigE Vision. With CoaXPress-over-Fiber, we are keeping the advantages of CoaXPress. So everything Patrick has talked about, I'm thinking about the triggering of the camera, sending data to the camera, the downward upstream channels, the fact that we use a frame grabber to unload the PC, very low CPU, very low CPU load. All these advantages of CoaXPress remain with CoaXPress-over-Fiber. In addition, we are going to benefit from the free, I would say, the natural evolution of Ethernet towards higher bandwidth. We are going to benefit from low-cost standard Ethernet components, such as the connectors and the cables. And we are going, and it's especially important, I would say, for camera makers, also maybe a little bit for frame grabber makers. Camera makers are going to benefit from common IP, I mean common know-how, knowledge, common IP and components between CoaXPress-over-Fiber and Ethernet and GigE Vision cameras. When I say we, it's the community. Euresys and Sensor-to-Image have originally designed the CoaXPress-over-Fiber standard, but it's now adopted by the CoaXPress work group, and it has been approved as an addendum to the CoaXPress standard by the JIA, the Japanese Industrial Imaging Association, at the beginning of this year. Of course, what we want to do is move towards fiber optics, which for high bandwidth application are much better than copper cables. With fiber optics, we will have access to higher, I would say, virtually unlimited bandwidth, unlimited distance, so practically much longer cables with more bandwidth, and less bulky and lighter cables will benefit from a complete immunity to electrical noise and a reduced power consumption. A drawback is that there's no such thing as power over fiber. We cannot transmit energy over the fiber optics, so we'll have to power the cameras separately. I will continue the presentation with a little bit more theory, but just a couple of slides to explain how it works inside a camera or inside a receiver. Then we will see the first practical examples and applications of CoaXPress-over-Fiber products that we have today. So on the left here of this diagram, we have a schematic block that shows how a camera on the top or a host implementing CoaXPress-over-Fiber works. We have an IP core, that's the block in green here, CXP device IP core, which is the core that implements the CoaXPress protocol inside the camera FPGA. data is transferred towards transceivers inside the FPGA that serialize the data and send them to the CoaXPress interface, either from microchip or MACOM. These are the two implementations we have today to inject data into the coaxial cable. With the CoaXPress-over-Fiber camera, the IP core, the CXP, the CoaXPress core remains exactly the same. So the protocol is exactly the same. We are transferring data to a thin new layer that we call the CXP-over-Fiber bridge, which is going to convert the data to make it understandable by the Ethernet core of the FPGA. And from there, we use standard Ethernet connectors and interfaces to access the fiber optics. So this new layer here in the middle is also standardized part of the CoaXPress standard. So we see the different standards involved here. Everything related to CoaXPress is standardized by the GIA. Then everything in blue there is standardized by the IEEE. Everything related to Ethernet is standardized by the IEEE, and everything optical is standardized by the SFF committee. So we are covered by well-known international standards here with CoaXPress-over-Fiber. If you are interested in developing products at Euresys and sensor to image, we sell these IP cores. So the CXP device IP core, the host IP core for CoaXPress. And we also have available the CoaXPress-over-Fiber bridge IP core that does the conversion between the parallel bus coming from the CXP device IP core and going towards the XGMI bus of the Ethernet PCS PMA interface. What is the current status of CoaXPress-over-Fiber today? We are working with several camera makers to develop cameras and to make CoaXPress-over-Fiber a reality. Actually, I have seen 4 cameras working so far. This camera is from IO Industries. That's actually a photo that was taken at the Vision Show in Stuttgart last week. That's an IOI Redwood 45 megapixel camera that uses a single fiber cable, the cable in purple color here. This cable replaces 4 CXP12 coaxial cables, so in a single fiber cable assembly. Another example of a CoaXPress-over-Fiber camera is from Vision Research. That's a view from our lab here. That's an even higher end camera. The CoaXPress CXP6 version used to use 16 CXP6 connections, and they have replaced this by 2 QSFP+, so 2 fiber cable assemblies to connect the camera to 2 frame grabbers in this case. We are also working with viewers in Korea and with CIS in Japan to develop cameras, and we are talking to all camera makers, and I hope optronists also very soon to develop CoaXPress-over-Fiber cameras. On Euresys side, we have for about 1 year now a frame grabber, which is called the CoaXLink USFP+. As you can see on this photo, it is a frame grabber with a QSFP+ connector here. What does QSFP+ mean? Actually, QSFP+ means quad SFP+, or 4 times SFP+, and SFP means a small form factor pluggable module. That's a compact network interface module, which is used for data communication, for example, Ethernet. It's used widely in data centers. With the QSFP+ slot or cage on the frame grabber and on the cameras, the 2 camera examples that you have seen in the previous slide also have a QSFP+ slot. We can use transceivers to convert optical data from the fiber into electrical data and vice versa. So at the bottom of the transceiver is the electrical connector. At the left of the transceiver here is the optical interface. It's covered by the black cover here. And so the transceiver is inserted into the QSFP plus slot of the frame grabber and on the camera. The clear advantages of this construction is that we can use different types of transceivers depending on the applications. With the QSFP plus transceiver modules, we have a bandwidth of 40 gigabit per second. This is exactly the same net bandwidth as we have with 4 CXP12 connections, so 40 gigabit per second. So this is where we stand today with CoaXPress-over-Fiber over QSFP Plus offering in a single fiber cable assembly 40 gigabit per second. But the clear interest of CoaXPress-over-Fiber is that this is opening a door towards much higher bandwidth. The QSFP28 standard is already available in the industry. At Euresys, we are currently developing a CoaXLink QSFP plus frame grabber, and QSFP28 means 4 times 25 equals 100 gigabit per second in a single cable. With QSFP56, we will have 200 gigabit per second, and the next standard is QSFP-DD, double data rate, that will offer 400 gigabit per second. So we have a clear evolution with CoaXPress-over-Fiber, a clear evolution of the bandwidth towards 100, 200, and 400 gigabit per second with a single cable. What kind of optical transceiver can we use? There are mostly 2 kinds that are popular today and that we are using in real applications. The first one is an MTP-MPO connector that we see in the center for a multimode fiber. Multimode fiber and this kind of connector are the lowest cost solution, and the maximum fiber length is 150 meters. So no problem for all these applications in machines and so on. A second solution is a monomode fiber with an LC duplex connector that can go up to 40 kilometers. No change to the camera, no change to the frame grabber. You just use a different transceiver to have access to up to 40 kilometers of cable. So a lot of interesting applications for sport, video, for remote inspection and remote video. There are other options, so MPO and LC duplex are the top 2 here. There are also breakout cables that can break the 4 connections of QSFP plus into 4 for 4 different cameras. There are also options using copper, using passive copper cable, active copper cable, and active optical cable that don't have a specific connector for the fiber, but the fiber goes directly into the transceiver. So all these options are compatible with CoaXPress-over-Fiber and the QSFP plus transceivers. So in summary, a lot of fiber options, opening up bandwidth up to 200 and 400 gigabit per second. That's what we are getting with CoaXPress-over-Fiber. Thank you.
Brilliant. Great presentation. Thank you very much, Marc. Very thorough, as always. If you've got any questions for either Patrick or Marc or any of the speakers as we go along, then please do drop them in the Q&A box on your screen, and we'll try and get to them at the end of all the presentations. Another technical question actually for Marc this time. The question is, can the QSFP frame grabber you presented also be used as a 4 times 10 gigi vision frame grabber? I don't know, Marc, do you...
No, it cannot. Actually, that's an interesting question for someone who followed the presentation, because the hardware is exactly the same. As I explained, the QSFP Plus interface is Ethernet. So it cannot be used with Ethernet or GigaVision today because the programming of the FPGA and the software, the drivers, do not support Ethernet and GigaVision. The hardware is the same, but the software is different. That's something that could come in the future, although we do not have any immediate plan with the CoaXLink USFP Plus to support GigaVision. But that's something which could come with some products in the future.
Okay, excellent. Thank you, Marc. I just wanted to ask, actually, maybe Patrick or maybe Marc or maybe Jack, I don't know, one of you, what about other pieces in the kind of the puzzle, the lighting and the frame grabs? I guess, Marc, you're probably best to answer that. But are they keeping up with the speeds of these, of the sensors and the interfaces?
Well, I'm happy to see these new sensors coming. I mean, and luckily, GPixel is before everyone, because camera makers need time to integrate the sensors, and then we need time to make the frame grabbers and develop then we develop the complete solutions, and so that's a natural sequence. So I would say that yes, everyone is moving forward. I have shown in my presentation that with CoaXPress we move from 50 to 100. It's where we stand today, and we have 100 gigabit per second with 2 CoaXLink USFP plus frame grabbers running in parallel. And then we are moving towards 200 and then 400 in the future. So we are ready with the new interfaces. We are ready for these new data rates. And as we explained, there is a high demand. We have questions from customers, from machine makers, because they have to inspect smaller and smaller defects at a higher number of parts per second, meaning higher frame rate. We have questions from customers who really need this kind of bandwidth today. And the frame rate means lighting that has to follow. Frankly, I'm not specialist in lighting, but I would say that it's not a problem to have lighting system at these frame rates.
Right.
Yeah.
Okay, I think the hour is up. So I think with that, I shall bring the web. Just to say, it will remain live on our website. That's www.imveeurope.com, and it will be there for the next 12 months. So you can go back and listen to all 4 speaker presentations again if you so wish. So it leaves me to thank our speakers, Patrick, Marc, Jack, and Win, and also our sponsors, Euresys, Scorpion Vision, and Optronis. And thank you all for listening. Have a good day. Goodbye.